Hi guys, welcome back. So today we're having a look at question 7b, and the reason that I specifically wanted to have a look at this question, by the way, this is page 402 in your textbooks. So the reason I specifically wanted to have a look at this question is because when I graphed it, I was looking for functions that fell below and above the x-axis. So I could show you how to calculate things that had the area under the curve. So what we're seeing here is we're trying to find from this bit here between -1 to this bit here to +1. Now, as you probably are aware from watching my last video, this here is going to have a negative value. And so since this value here is negative, we have to find the absolute value of this. So we can do that in a couple of different ways. As you saw in the last video, I think the easiest way is just to determine what the area is and then to just make it the absolute value. Now, the other thing is when we find the area from 1 to -1, you can see here at the point x is equal to 0, it actually flips over to being a negative curve. A positive curve in the positive range. So when I calculate this value here, those values are going to be positive. So effectively, my strategy for this particular function is going to be that I'm going to find the area of this first. So let's call this A1, and then I'm going to find the area of this. So let's call this A2, and then I'm going to add the two absolute values together for that area. So let's jump back and let's have a look at what the equation actually is. So determine the area. So area just means that we've got to integrate between -1 and 1 of the function x over x squared plus 2 dx. Now, as you can see here, we're going to have to break this up into two different zones. So the first zone, I'm going to find the area, the area from -1 to 0 of our particular function. So that's going to be our x over x squared plus 2. And we're going to find the absolute value of that because that's going to be our negative component. And then we are going to add that to our area 2, and that's just going to be the integral from 0 to 1 of our function with respect to x. And we don't really need to put the absolute brackets around this one because this one will already be positive because it's above the x-axis. So let's go ahead then and let's actually determine what the integral of this function is first, and then we can go ahead and we can substitute in all of those values. So for this one, again, there's a couple of different ways that we can do this. So integration by parts or by using partial fraction decomp. I'm going to leave that up to you as to how you want to solve that. And all I'm going to do is I'm just going to pop the integral on the screen. All right, so I just went to the integral calculator online to solve that. So again, if you do want a specific video on how to integrate this function, you can go check out any of my other videos, or you can send me a question or send me an email, and I can go through and show you how that works. But I think at this stage, that should be a pretty straightforward integration. Okay, so now that we've got that value, now we're not going to add c to the end here, just because that will, when I subtract one from the other, it will end up just removing that value for c, so we don't have to determine it in this case. So let's go ahead and let's find this particular, our integral from -1 to 0, and we're going to find the absolute value of that first. So substituting in these values, I'm going to have ln of x squared plus 2 over 2, and we're going to do that from -1 to 0. So that's just the first area that we're working out now. We're not working out this bit just yet. Okay, so let's substitute in. So we're going to have ln of -1 squared is 1, 1 plus 2 makes 3 over 2. Take away ln of 0 squared is 0 over 2. So that just becomes 0 plus 2, which is 2 over 2. And then just substitute that into our calculators to get that result. All right, so that's worked out to be positive 0.2 as our result, because what I did was typically what I should have done, I apologize, I should have done ln of 2 over 2, subtract ln of 3 over 2, but then that would have given me a negative result. So I just swapped those around. Sorry I didn't make that clear when I did that. Okay, so let's go ahead now and let's do the same thing for area 2, and then we can add those two values together. So we're going to do for that same function, so ln of x squared plus 2 over 2, and this time we're going to go from 0 to 1. Now this time I am going to put them in the correct order, so this is going to become ln of 1 squared, which is 1, plus 2, so that's going to be ln of 3 over 2. Take away ln of 0 squared is 0, plus 2 is going to make 2 over 2. We just did this calculation, so we know this calculation is also going to be equal to 0.2. And that makes sense that they're the same size, because if you have a look at the graph, it looks pretty symmetrical around those points. Okay, so adding those together now, we're going to get our answer is 0.40, and that's with some rounding. So keep that in mind. So that's the area under our curve between -1 and 1. So jumping over to the graphics calculator now, let's go ahead and let's pop that in, and I'll show you what the graph of that looks like using the graphics calculator. So just like in the last video, we're going to jump back into graph. I've popped my function in there, x over x squared plus 2. We're going to draw that. Now, the problem with this particular function here, or the problem with your graphics calculators, if I was to use that same method, so gsolve, and then we want to find the integral, and we want to do that from -1 to +1. So if I scroll back here, -1, that's my first, my lower bound curve. So if I now scroll across, I'm guessing you can probably see what's going on here, is that when I have just from -1 to 0, this is actually returning a negative value. So if I keep going across and I was to go and put in b is equal to 1, because that was my original value from -1 to 1, you can see here that the area under the curve is going to be equal to 0. And that's because your graphics calculator doesn't really take into account the fact that it's underneath the x-axis and therefore it's a negative value, or it's above the x-axis and therefore it's a positive value. So what we actually want to do, we want to determine the total area between the curve and the x-axis. And so we're going to have to go in, and we're just going to have to go to 0, because that's where the curve is in the negative zone, and we're going to have to write that little number down, so -0.2, just like we said before when we did it by hand. And then we should find that if we do the same thing from 0 to 1, that's also going to be the same value. And so when we add those two absolute values, we still get our result of 0.4 as the total area between the x-axis and between our curve. Okay, so I hope that that's sort of clarified things a little bit. Looking at areas beneath and above the curve. So just be very, very, very careful with using your graphics calculator for these kinds of questions. And just make sure that you are really understanding what the graph looks like. So that may mean that you have to draw the graph on your graphics calculator and look at the area if you are in a tech-free exam. Alrighty guys, I'm just going to leave it there. Have a wonderful day, and I will see you in the next video. Bye guys.